Being able to get directions without looking up, well, that would sure be a nice thing. And Chen, your product here allows someone to do that. Why don't we talk about that capability, and we'll have a conversation about where this product is going.
Sure, yeah. Thank you, Ken, for stopping by. What we're building here is an AI-powered AR navigation for driving. What that means is instead of the drivers using Google Maps or Waze or Apple Maps that shows you directions on a 2D map, that can become confusing, not knowing which turn exactly to make, and also interpreting the map, taking your attention away from what's in front of you. And so we thought, why don't we show you the actual live feed from your phone's rear camera so that you see exactly what's in front of you with the overlay that we do for you, so you know exactly where to go with a quick glance and without needing to read the map.
Now that's a great application, but it really kind of underplays the technology that's underneath this, right?
Yeah, thank you for pointing that out. So in fact, we are an AI-powered AR navigation for driving, and because in order for us to build that AR overlay that's accurate and precise and smooth, we have to build an AI that understands for you what's in front of you. The lanes, where are the drivable region, where's the shape of the ground plane, and objects and all of that. And that's why we've built out all the AI ourselves that can run efficiently on the phone or in real time at the same time, not overheating the phone and not draining out the battery. And we use that to build out our AR navigation.
And that's got to be very powerful moving forward as you start to do things, other safety things.
Correct. And so by going into AR navigation first, we're able to then add more safety features onto it, such as lane departure warning, frontal collision warning, pedestrian detection warning, even rear view, blind spots. So those will be added on later on.
And so from a go-to-market strategy, how is this being brought to market?
Yeah, so initially this will be a free app that you can download as a user as long as you have iPhone 7 or later. It'll just be free, download, mount your phone on the windshield or on the dash. And we're also talking to car makers, suppliers to build it into cars. And for example, showing AR navigation on center console display or projecting to the windshield. We're also talking with smart glasses companies to build it into smart glasses.
And so from a Android perspective, will it be available on Android as well?
So Android will be our second wave of launch. First, we're focused on iOS because there's only Apple making iPhones. Android, there's a lot of different makers, so that's a second wave after iPhones.
And now you also mentioned off camera that you actually went beyond the Apple and the Android tools for doing augmented reality. You had to actually get into the guts, it sounds like, right?
Correct. So Apple has something called AR Kit that allows developers to build AR applications. Google Android has something called AR Core. But ARKit and AR Core was not designed for high-speed type of movement, and therefore we couldn't use ARKit nor AR Core. We had to build our own AR technologies in order for this to all work. So in the end, we ended up building everything on our own and without using any dependencies.
And so from a data collection standpoint, you're gaining a lot of knowledge about the streets and driving and so forth. Do you anticipate that being used for, autonomous driving in the future?
Absolutely. Our aim is that with our users' consent, we'll be able to crowdsource the world's live visual data everywhere our users drive. So that can allow us to collect live traffic data and also allow us to collect live visual data of everywhere they've driven so that we can crowdsource 3D HD map that's actually the backbone for self-driving cars to be possible.
From a data perspective, though, is it going to be a huge load on the customer's data plan to transmit that data?
Another great question. The live traffic, so the live traffic data, we only upload the metadata, that's after the detection. But for the actual 3D map generation, those data, those raw video footages will be saved on your phone, and they'll be uploaded after you're connected to Wi-Fi at home or at work, so that it won't eat up your data plan.
And so from a privacy perspective, that's got to be huge because you know where everyone's going. So how do you protect privacy?
So we take our users' privacy very seriously. First, our user has to consent to us collecting the data. And secondly, we don't collect any identifiable information, nor do we use them for any monetization purposes. Third, we deliberately blur out all the identifying information on the fly, on the phone, before we even upload the data to our server. That includes license plate data, face data. So we try to be as diligent as possible in terms of privacy.
Wow, that's incredible. So you're doing, and you can see in the background the lane instant segmentation. It seems like a huge opportunity for the retrofit market, as well as you were mentioning the OEMs to implement this themselves.
Yes, so what we're doing, because we've developed our own AI as well, and therefore this super efficient AI can also be related to helping self-driving car systems to be less dependent on heavy hardwares, and also car makers to help them build, to allow them to integrate our solution with much cheaper platforms.
Well, that's excellent. Chen, I really appreciate your time as I'm looking at the people semantic segmentation in the background there. That's amazing. Good luck.
Thank you very much, Ken.